Hi guys, and welcome to this other exciting session in which we are going to look at the Onnx format of representing machine learning models. Don't forget to subscribe and hit that notification button so you never miss amazing content like this. Onnx actually stands for Open Neural Network Exchange. This open standard for machine learning interoperability was co-developed by Microsoft, Facebook, and AWS. And in this session, we'll learn how to convert our already trained Tensorflow model into this Onnx format and then carry out inference on this our newly created Onnx model. So we've gotten to this point where we've fine-tuned our Hugging Face-based vision transformer model. Now we have this Tensorflow model which we've created and evaluated, and it may happen that another developer using a different framework, like for example PyTorch, wants to make use of this model which has been trained in TensorFlow. So thanks to the Onnx format, we can now convert this code which was written in TensorFlow, or rather convert this model which was built in TensorFlow into an Onnx model, and then later on convert this model from the Onnx format into PyTorch, such that we now have this PyTorch model which this other practitioner can use. Now another possibility is the reverse. That is, we could go from this PyTorch model to a TensorFlow model thanks to the Onnx format's interoperability. Another reason why a developer will want to take this model from PyTorch and make use of it, say in Cafe for example, maybe because that model is more efficiently run in this other framework. And the reason why we have these kinds of differences for different frameworks is because, for example, you could have a convolutional neural network or a convolutional layer which is built in PyTorch with a certain implementation, and the implementation in Cafe may be slightly different and maybe more efficient as compared to that which was done in PyTorch. Now this is just for demonstrative purposes, and we are not saying that the implementations in Cafe are better than those in PyTorch. And so in summary, the Onnx format allows models to be represented in a common format that can be executed across different hardware platforms using the Onnx runtime. So now developers can feel free to build their models with just any framework, say for example TensorFlow or PyTorch or Paddle or whatever framework they actually want to work with, knowing that they could deploy your model on whatever hardware they want to, since they could now convert these models to the Onnx format and then run inference on these models via the Onnx runtime, which is in fact an inference engine which is lightweight and modular and permits us run our Onnx models on just any hardware we choose to work with. So here let's look at the list of supported hardwares. You see, for example, the Tensor RT, which is very popular with the NVIDIA GPUs and permit us to attain very high speeds when carrying out inference on neural network models. The other great advantage of working with the Onnx models is the ease with which we could convert TensorFlow models into this Onnx format. So right here you see we evaluating our model, this Hugging Face model which we fine-tuned previously, and we getting 90% validation accuracy. Now we could go ahead and save this model. So here let's take this off, HF model, let's call this Hugging, or let's call this VIT fine-tuned. Okay, so that's it. We have this fine-tuned VIT model which we're going to save. We could check this out here. There we go. We see a VIT fine-tuned, and you could check. You see you have the saved model, Keras metadata, variables, the assets folder, and then here if you could see that this is almost 1 gigabyte model. So you could view this here. You see 984. Just check as I hover on this. You see here 984.39 megabyte model. And so this means that if you were to deploy this in a real world scenario, then you will need to always allocate this amount of space in order to run this model. Now let's move on to converting this model into the Onnx format. We shall have this two installs. So we'll start by installing the Tensorflow to Onnx tool, and then we'll install the Onnx runtime. So we'll run this, and then now we'll go ahead to convert our model, which is this one here, Vite fine-tuned. So we just have to specify your Vite fine-tuned into the Onnx format. So here we just say Vite fine-tuned, and then now we have this model. I'll give it this is the name of our Onnx file. So we'll call this Vite Onnx. That's it. Our Vite Onnx tf to onnx.convert, and that should be it. So now we'll run this. Then while waiting for that run to be complete, you could get to the Onnx GitHub repo, Tensorflow Onnx, and then you'll have the documentation for how to convert from Tensorflow to Onnx. So let's get back to this. It's still running. You could see we have a series of warnings. Then specifies the TensorFlow and TensorFlow Onnx and TensorFlow to Onnx versions. Then the offset. Then it's optimizing. And now we have this successful conversion. So Onnx model is saved as Vite Onnx.Onnx. Now let's open this up. You see, Vite Onnx.Onnx. You see, we've moved from this. Let's open this again. We've moved from this here where we had 984.39 megabytes to this optimized Onnx version, which is at 327 megabytes. Now another option will be to convert the model from this Keras format to the Onnx format. So this first one, we saved this as a TensorFlow saved model, and then now we could just have this here. So let's say we have the model, we saved this as a Keras model. So we have .h5 and we run that. Checking here, you see we have this still 984.98 megabytes, close to 1 gigabytes. And then from this Keras format, we are going to now convert this to Onnx. Now here we're going to have this specification, and then we'll pass in the image size. So here we have the batch by 256 by 256 by 3. It's float 32 and is our input. Then we could specify this output path. So this one was Vite Onnx. Let's have this as let's call this our Vite Keras.Onnx. Okay, so this is going to be our output path here, and then we'll have this TensorFlow to Onnx here, which contains this from Keras method, which takes in our model, Hugging Face model, and then the specifications which we just mentioned right here. So here are our specifications right here. We pass this in this or pass this as our input signature. We have this offset value, and then we also have our output path, which we have already specified here. Then we have our output names, which we shall get automatically. So that's it. Let's run this. While that's running, also note that you could check out these conversions on the Onnx runtime.ai platform, where you can get the details of all what we're doing. So let's get back here. Still running, and that's it, complete. Let's check out our Vite Keras. You see 327.59 megabytes. Then from here we move on to the inference, where we'll see whether what we get from the Onnx model coincides with the initial Keras or TensorFlow formats. So right here we have this provider. Now here we specify this provider to be this CPU execution provider, as we'll be running this on the CPU. And then we have this Onnx runtime as RT, which we have imported right here, and which we're making use of here. So when we want to run an Onnx model, you see, the first thing you have to notice, we do not need TensorFlow anymore. So even if we restart this whole process, all we need to do will be just to install the Onnx runtime and then import this way. So now we have our Onnx runtime. We have this inference session which we create by just specifying this path, our output path here. Our output path is the path to this model, the Onnx model, and then the provider is this one here. So we just need to specify this path and the provider, and we're good to go. So now we have this. The next thing we want to do is to run the inference. So the Onnx prediction is this m.run, and then now we'll specify the output names. Now this output names is gotten from here. So let's run this. Let's print out output names so you see what it contains. That's it. You see we have that dense, and if we get back to when we're creating this model, let's get back to this. Okay, you see the name here we have is dense. So if you specify the model name to be different from this, you would have a different output name. So that's it. Let's get back to our Onnx inference. We've converted already, and that's it. So that's it. We have our output names which we created, or rather which we generated automatically from here. That's it. And then obviously it's a list because we could have several outputs. And then from here we pass in our input image. Now this our input image is simply what we've been having already. So we could copy this, and then test this out here with our Onnx model. Let's have this here, add this code, paste this out. All we need here is just this basically. So we could run this. Let's run this. That's it. We have our image, and then let's run this. And yes, let's run this, and then we print out the Onnx print. So we get in input must be a list of dictionaries or a single numpy array. So what we're gonna do here is, instead of TensorFlow, we use numpy. So you see already that we do not really need TensorFlow. Like even with this, we could get the test image from here. Let's get this test image directly. So we could have test image, and that's it. We run that. We have our image. This not defined. Test image. Let's run that again. That's fine. We get this other error because this input isn't a float. So here, instead of this, we're gonna have test image dot as type np dot float 32. Okay, so we have that set. Now let's run this again. No, before doing this, let's make sure we pass in this image instead here. So we have that. We run that. That should be fine. Okay, so let's rerun this again, and you see we have now our Onnx spread. So there we go. You see it shows us that it's a sad image because this is angry, happy, sad. So it's sad because the sad has the highest probability, and you see the image here is sad. Now if we get back to the top here and simply run this, it's the same image. Let's run this. Let's get the probabilities actually. So let's say we want to have let's print out the model image. Let's get those probabilities. You see this is what this model gives us as output, and here's what we get from the Onnx model right here. Now before we continue, another thing we would like to check out is the speed, or the time, or the latency of the model. So let's get back up here, and we could add this code cell. Let's import time, or we could just do it below. So let's yeah, let's just do that below. So let's take this off, and then here we could say we want to have, let's import time. There we go. And then we have t1, which is time.time, and then we do HF model, taking an input image. Then we record the time, the current time minus the t1, so we could get the time which is elapsed after running this model. You see 0.14. That's a 0.14, and you should note that here we're supposing that we're running this on a GPU. So you check manage sessions, we're running this on a GPU. Now for the Onnx model, we could have here t1 time.time, and then we could print out the difference in time. So we have that minus t1. Let's run this and see what we get. Input list a single numpy. Let's run this again. Okay, so you see with we're making use of the CPU, and we're getting 0.279 seconds, while with the GPU here we're getting 0.143 seconds. Now we can be comparing the Onnx runtime results on the CPU with that of this Hugging Face model with TensorFlow on a GPU. You could even see from here, if you do get device, you'll see from here that what the Onnx runtime is using is the CPU. And so if we want to make use of the GPU, we would have to install Onnx runtime GPU version, so we could compare the two models. So for now, just note that TensorFlow with the GPU is 0.15 seconds, and then we'll need to get TensorFlow with the CPU, and then we'll also get we got Onnx with the CPU. Onnx with the CPU gave let's say 0.3 seconds, gave about 0.3. Or let's run this again. If we run it again, we should get, let's run this again. Oh, getting an error. Now that was because I had moved this file into the drive. So here we have the VKeras here, and we run this again, we have about 0.38. You see, that's it. About, okay, let's say 0.5. So let's say this is 0.5 here, and then we need to get Onnx with the GPU, and then we also need to get a TensorFlow with the CPU. So that's it. What we'll do now is we'll go ahead and install the Onnx GPU. So here we have pip install Onnx runtime GPU, and that should be it. We already installed this. Okay, so we have this Onnx runtime GPU, and then if you do import Onnx runtime as RT, and then you as RT, and then you say rt.getDevice, we are getting the CPU. So what we'll do now is we are going to restart this runtime. So basically restart this runtime so that the GPU version of Onnx will be taken into consideration. Now this time around, we're going to install Onnx runtime with the GPU. And that's it. As you can see now, the device we're using is a GPU. Okay, so we have that. Let's now get back here. We already have our model in the Onnx format. So we just run this. And then if you run this, you'll see that since we will specify the provider to be the CPU, we shouldn't have any much difference here. So let's run this again. We imported time. Output names not defined. Okay, our output names is basically this. So let's have this list and let's define this here. So let's have output names. Output names. There we go. Output names dense. So let's run that again. That's fine. And then we get back here. But note that this output names was generated from here. So you could get back to start generating this, or you could just make use of the output names. As you can see, since we restarted this runtime, we do not have those files anymore, apart from the Onnx which we stored in the drive. So if we have to do this, we will need to retrain our model since we lost them already. Okay, so we have our output names here which was specified, and then we get back here, we run this again and check out on the time it takes to run the model. You see 0.34, not bad. 0.34. okay, let's say 0.34. so here normally this should be 0. Yeah, let's say 35. Okay, so the TF with GPU 0.15, Onnx with CPU 0.35. Now the way we're gonna use this is we'll get here, you see, in this documentation you have the provider here, we specify the CUDA execution provider. So let's copy this and then paste it out here. So instead of here, for example, instead of CPU, now we have the GPU, so we could make use of the CUDA execution provider. So here we'll take this off and then paste this out. So this is our provider now. Note that since these providers can be a list, you could have several providers. Like here, when we do this, when we have CUDA execution provider before the CPU execution provider, it means that the priority goes to the CUDA execution provider. And so in the case where we are having a CPU, then we will start with this one, and given that this cannot work in the situation of a CPU, we will then move on to this. But if we have a GPU, then directly we will use this CUDA execution provider. And that's it. You see, 0.048 seconds, or let's say 0.5 seconds, which is 3 times less than what we had when running our model or when running the Tensorflow model. So you see already that the Onnx framework permits us to optimize our initial Tensorflow model. So here we have Onnx GPU. Now this is 0.05. So it takes us now 50 milliseconds to run this Hugging Face model. So that's it. Now before we proceed, it's also important to note that generally the way we measure this time it takes for the model to predict an output, we usually can test with several input images, or we could repeat this process several times. So let's say for underscore in range, let's say 10, we run this and then we get the time elapsed. Instead of just testing once, we could test 10 times, so we could get the average. So let's run that, and you see, dividing this by 10, we have 0.035. so that's 35 milliseconds per prediction. So this means that for us to have 100 predictions, we would take 3.5 milliseconds. We could test that out. Let's run this, and there we go. We take 2.3 seconds for 100 predictions. Now if we divide, let's call this number of predictions, we'll set this to be 100, and then the time taken, this is time for a single prediction. There we go, time for a single prediction. All this divided by the number of predictions, so we get the average. That's fine. So let's run that again, so we could get this time. Okay, so we see 0.023 seconds. That's 23 milliseconds. While if we repeat the same for the Hugging Face model, you see it takes 0.15 seconds, just as we had already. Now we could see that the difference in speed here, 0.15 divided by 0.025. You see the Onnx model is 6 times faster than the Tensorflow model. Now what if we get back and run the Tensorflow model on the CPU? So we change this runtime known and we save that. So we'll have to rerun all this again. Now running our Hugging Face model here, You see this takes 0.8 seconds, 0.8. So with the CPU, we have 0.8 divided by 0.35. The Onnx model runs about twice as fast as the TensorFlow model.